Good afternoon. Welcome to our discussion session this week. And in this week, we'll talk about problem 7.2.28 on the book. First, let's see what the problem is. The problem tells us that a family has 5 children, and the probability of a child to be a boy is 0.51. Since there are only 2 sexes, so easily the probability of a child to be a girl is 1 minus 0.51, so it's easily 0.49. And now let's see what the problem asks us to do. The first thing he asks us to do is that what's the probability of the family to have at least 1 boy? To deal with a probability problem like this, we also divide and conquer the problem. For example, the problem tells us that it has at least 1 boy. So how can the family to have at least 1 boy? It can have 1 boy, 2 boy, blah blah, to 5 boys. But obviously, the way to add all these probability together is very tedious, and we must do all these things again and again for 5 times. It's not good for our class. So what we must do is remind something from your proposition class. The negation of proposition. For example, the negation of at least 1 boy is less than 1 boy. And obviously, this thing equals to no boy. So we only need to calculate the probability of the family to have no boy and use 1 to minus it. So how to calculate the probability of have no boy? It's easy. That no boy also is equal to 5 girls. So the probability of have 5 girls is 1 girl's probability, and it has a factor of 5. So probability of have more than 1 boy is use 1 to minus this. So we can easily solve this problem. And for the second problem, it asks us to calculate the probability of all children to have the same sex. This problem is easier than that because we only have 2 situations to have all the children to have the same sexes. The first is they are all boys. The second is they are all girls. And all girls' probability we have just calculated there. It's this. And similarly, we calculate the probability of all children to be boys. They are similar. And we add them together. It's our answer for problem D. So we easily solve this problem. To conclude this problem, I must remind you that when you deal with problem like that, you divide it into different sessions. If you find that your situations is not very complicated, you can just calculate all this probability and add them together. If you find that the situation is very complicated, you can use something from proposition that maybe negation, or sometimes maybe some other proposition, some other logic more than negation, and you can solve the problem more easier. If you want to add all 5 probabilities together, you can also do this, but it's a little complicated and waste of time. So we use this kind of solution in this problem.